Hi, this is James Cook of the University of Maine at Augusta, and I'm sharing this video on behalf of the social science program, both for our courses in social network analysis and analyzing social media. What I'd like to talk today about is the idea of crafting cultural networks, also sometimes called semantic networks, social networks of meaning that are not divorced from the social structural basis of that in sociology, but actually are expressed in some new insights as an aspect of social structure, bringing together the idea of affiliation, connection, and culture in a really exciting new way. Now, I would like to state right from the get-go that these are not my ideas. Rather, they're recent developments of some classic sociological thinking. Perhaps the best classical conception of this, which is both theoretical and mathematical and simple, was created by Ronald Breiger in 1974 in a piece called The Duality of Persons and Groups. Scott Feld in 1981, a few years later, created a more general, less mathematical idea of the same concept in foci, and that's also worth reading. The theory behind it all, the dead European white guy, is Georg Simmel, who at the beginning of the 20th century, with a book that was published in English in the 1950s, crafted an essay in German. The original was Die Kreuzung sozialer Kreise, the intersection of social circles, translated as the web of group affiliation. And you can read it in this small book that's available through Free Press. And then in the early 90s, Kathleen Carley, a sociologist working out of Carnegie Mellon University, starts to make theoretical arguments, also couched in mathematics, that describe the way that cultural similarity creates group stability, and that group stability creates cultural similarity. That starts to sound a lot like the argument that Ronald Breiger makes. And the basic technique that I'm going to talk about today comes from Breiger and is really expressed in a wonderful piece of writing that is both a teaching piece of writing and a very important conceptual piece of writing. And that is called Semantic and Cultural Networks by Shugars and Sandra González-Bailón in the SAGE Handbook of Social Network Analysis. I think that this article is worth the price of significant price of buying the SAGE Handbook of Social Network Analysis, second edition, alone. There are some other pieces of work that are also recent and also describing that kind of thinking. I don't think they're quite as clear to a newcomer, but Nikita Basov and colleagues, and notice Ronald Breiger is still at it. It's an amazing figure of sociology. Ryan Light, and then Sophie Mutzel, a colleague of Ronald Breiger, and Ina Helston are doing some really great work with their colleagues in that regard. So if you're curious about that, please read further along these lines. Let's look at the conceptual center of Ronald Breiger's 1974 work, The Duality of Persons and Groups. So the argument here is fairly simple, but it's represented in the idea of starting really at the bottom here in what's called an affiliation matrix, although here it was early days, so it was called an adjacency matrix of people to groups. But the idea is that you look at those letters in this table at the bottom. That's C. A, B, C, D, E, and F are thought of as people. They could be Al, Betty, Cleo, Dan, Enid, and Frank, or something like that. And then imagine that there are groups, group 1, group 2, group 3, group 4, and group 5. They could be committees in a corporation. They could be social clubs in a town, anything that people can belong to as a social entity. And then there are zeros and ones. So the way you'd read this is to say A belongs to group 5. There's a 1. 1 means yes. 0 means no in this matrix, this table. So A does not belong to groups 1, 2, 3, 4, or 5. Person B, on the other hand, belongs to group 1, but not groups 2, 3, 4, and 5. The person C belongs to more than one group, both groups 1 and 2. And the idea that is expressed, by the way, through matrix multiplication of the original matrix and its transpose, you can read more about that in Breiger 1974, is that, however, that this affiliation matrix, which is really just a set of membership lists, right? One of the easiest things to get when it comes to social data about the groups that people belong to, creates actual additional information. First, Breiger says, harkening back to Georg Simmel, that when people are in groups together, they spend time together. They work on projects together. They speak and listen to each other. They do all that kind of joint activity that leads to connection. Pro tip, if you're lonely, join some groups. And as a matter of fact, what that means is that given that affiliation matrix at the bottom, this idea of who shares groups with whom, note that B and C share a group. If you look at C, right, they share one group. C and D share one group. D and E and F share group 3. And interestingly enough, D and F share, D and F share 2 groups. Yes, if I'm looking at that correctly. They're both in groups 3 and 4. That leads to ties. And where one group is shared, it's a tie strength of 1. And where there are 2 groups shared, it's a tie strength of 2. Now look at that matrix B1, an adjacency matrix, which adjacent means you're next to, you're tied to. It's a network of ties. Now, both the rows and the columns are letters, A, B, C, D, E, F. Breiger is arguing in this one figure a really important point that's non-mathematical, but expressed in math, because math is just the very specific expression of an idea, which is why it's good to learn a little math, that ties between people are created in groups. And if you only know the membership lists, and that's all you have, you nevertheless can impute, you can theoretically predict where the ties will be. And by the way, the network graph above matrix B1, network graph A1 represents the ties, where the circles are nodes and the lines are connections between them. So D and F have a network strength of 2, expressed as 2 lines here in the graph above, and expressed in the matrix with the number 2, because they are in 2 groups, and so they have twice as much of an opportunity to form connections as, say, people B and C, who have a connection strength of 1 because they share one group, have one context in which they can get close to each other and form a social tie, a bond. And A and B share no common groups, so A and B have a network strength of 0, no connection, at least no direct connection. And then he does this really cool thing. He takes a step and says, wow, you know, it also, that kind of membership of people in groups connects groups. And think about it. Groups are an entity that exists above the level of an individual, hence sociology. The world is not just individual people, there's things above that level. Groups share ideas, culture, practices. Why? Because there are people who are in both groups, and say you're in, I don't know, the Urban League, and you're also in the Rotary Club, and so is a friend of yours, both in the Urban League and the Rotary Club. Well, that's two people who are in the Urban League. And so when the Rotary Club meets and says, oh, how are we going to vote on this issue? These two people from the Urban League have a chance, an opportunity to speak up and say, oh, well, over in the Urban League, we do it that way, says one person. And then another person says, oh, yeah, she's right, and reinforcing that, leading to connections, flow of information, ideas, cultural practices, and things like that between groups. Group 2 shares one member with group 3. They have a connection of 1. Because group 3 and group 4 share 2 people in common, that is D and F, groups 3 and 4 are doubly strongly tied. And that's represented in both the matrix B2 and the network A2. The idea is that individuals form ties with other individuals in groups, and by individuals being in groups, they also create ties between groups. So that's like this multi-level thinking about social structure and how groups and individuals are connected. It's a wonderful thought piece. It's a relatively small number of pages, and if you can work through the ideas of matrices in that regard, you've really got a very powerful idea. Okay, Shugars and González-Bailón in 2022 are basically saying something very, very similar. What they say is, in just boiling down their very well written work into a few words, is that there are these cultural expressions, texts, images, video, sculpture, anything that can be a mode of cultural expression, right? And then when there are two cultural expressions that share cultural content, or when one cultural expression shares more than one piece of cultural content. What is cultural content? Values, what you think is good or bad, beliefs, what you think is true or not, symbols, letters, memes, things like that, and expectations for behavior. That's cultural content. When those things are shared, the sharing of cultural content between cultural expressions creates ties between cultural expressions and ties between forms of cultural content in this dual formation of networks through shared meaning in cultural forms. Wow! That's cool too. So what that means is that ideas enter into the mix. This is a really powerful idea, and it suggests a whole new arena for the incorporation of culture into discussions of social structure. That culture actually represents a form of social structure. So what does this cultural analysis look like in practice? Well, one of the first things you need to do is get some cultural data. One of my areas of specialty in research is in social media research, and so as a consequence, I've figured out some ways with some help from a community of academics to collect social media data. One of those academics wrote an R package called Reddit Extractor. R at r-project.org is a statistical package and methodological package that allows you to gather and manipulate information and analyze it. and the package Reddit extractor was written in order to look at information on the social media platform Reddit and grab information from it. And so running our studio, which is a shell for R that makes it a little bit more user-friendly, I've written a script in which I'm looking for information from two subreddits. I've been collecting data for about 4 years now on public communications by pseudonymous individuals, so none of whom share their names, regarding their perceptions and experiences regarding two ethical non-monogamy practices, one of them being swinging and the other being polyamory. And the two subreddits or discussion boards on Reddit that are the most popular in those domains are the subreddit swingers and the subreddit polyamory. Now, I have a number of research reasons for collecting that information, but one of the things that I've become interested in is the idea of the cultural value placed or the cultural beliefs about regarding individuals with different sexualities in the swinging community and the polyamory community. And comparisons of the two have not been forthcoming in formal academic research, but there's this long-standing set of descriptions of the community by these communities themselves. Here's one example from Skeeter Sanders writing in 2013. It's not exactly a secret, writes Skeeter, that much of so-called biphobia is really homophobia against bisexual men, and that's in straight society. Within gay community, biphobia is heterophobia against bisexual men. My wife, who's heterosexual, and I are both polyamorous. I've been targeted, and so Skeeter then goes on to say that there are lots of references to bisexual women who are polyamorous, but no references at all to bisexual men who are poly, short for polyamorous. So making contentions that there's, number one, a distinction between bisexual men and women in the polyamory community, and second, a set of moments of discrimination within the polyamory community against bisexuality in general. So there's a lot to unpack there, right? And this is just one person saying something, of course. And this is in a comment to the blog Poly in the Media, which is describing different attitudes that are expressed in different forms of media. But that's all anecdotal, right? Or stories that are told by individual people. If we look systematically at these discussion boards, at these places where people come to express ideas about asexuality, say such as bisexuality, within the polyamory community and within the swinging community, what trends will we find? What ideas are associated with, for instance, bisexuality? Are they different for the two communities? And also, are they different for different categories of people? For instance, Skeeter Sanders is indicating a belief that there is a distinction between perceptions of bisexuality in men versus bisexuality in women. Wow. Well, we can start to figure this out by looking at one place where that discussion happens, and here's Reddit. So what this script does, first of all, is it after installing, you have to, under Tools, in the drop-down menu, hit Install, and then install the package Reddit extractor, and then the library command activates it. Lines 3 and 4 and 6 and 7, which are parallel, gather first a list of threads, which is main posts, within a particular month. I ran this in March 1st of 2023 for both the swinging community and the poly community. And then it looks for comments underneath that. That's lines 4 and line 7. Having gotten the thread information, it goes and it further fetches comments. And then there's a series of commands to write the results out to a CSV file, which is a comma delimited file, which is short for a universal spreadsheet file. And the result that I get looks something like the following. So I get a list of threads here. This is one of the files that came out. This is for polyamory, which is indicating URLs in the first row. That is, if I want to go and actually look at these posts themselves, it gives the names of authors, but keep in mind these are pseudonymous, which is really important. People don't use their real names on Reddit, so even though it's public, there's very little risk that individuals' names are going to be associated with these comments. So that's kind of a double ethical protection, which is important when we're talking about marginalized communities like swingers and polyamory folks. Then there's a date for when that post was made, and then I'm going to expand this column E. There's a title involved there. And then if I really expand column F, if I'm allowed to do that, it looks like my computer's freezing just a moment. There we go. There's a lot of text here in the comments. And these are people making their main posts here in which they're describing their thoughts about some subject, the subject that is described in the title. Now, there's also, if I wanted, a separate spreadsheet that was generated by that script, and please feel free to use that script. I developed it with inspiration from others, and you can develop yours with inspiration from mine. There's a comment row here, so all the comments from all those posts in the polyamory subreddit that I accessed, looking back about a month from March 1st, 2023. We could, switching back, we could take a look at the number of posts within this time period, about 988, and then we could take a look at the number of comments. And the number of comments is 24,280 minus the top for the header, so 24,279. That's a lot of posts and a lot of comments. Within the comments, if I am searching, Control F, which is our friend, although I think I may want to, yes. If I just simply type in bisexual and then click Find All, I'll get a very quick count of 100 cells in these comments in which bisexual appears. Okay, so and then if I head over to the main first posts that generate comments and the text of those, and I search there, and I'm looking for bisexual, and I want to find all, I'll get 23 responses. So one of the things I can do here, once I have this data, is to begin to think about the idea of utterances that express cultural values, beliefs, and expectations, and see how they are associated with categories, such as individuals indicating bisexuals. How are the bisexual individuals described? I can go through and perhaps find each of the references in which the exact word bisexual is used, although it's really important to look for synonyms. And then I can look at the description of how those people are depicted. They could be adjectives describing beliefs about how people are. They could be normative statements about people are good, they're bad, they're neutral statements. They could be expectations describing the kind of behavior associated with bisexual people. So notice that is what's called that's the duality here. And that could create in a third spreadsheet, which I'm going to show you a little bit of today, the idea of categories of people such as bisexuality or bisexual man, bisexual woman, perhaps bisexual non-binary person, if we find that here, and then cultural ascriptions, cultural descriptions of such people within the poly community. What I'm going to do now is pause the video and do a little bit of coding to generate an example of that. And then we're going to talk about how we can go back to R, which manipulates information, and we can upload that affiliation matrix describing positions versus cultural ascriptions, and then we can turn those into themselves three forms of a cultural network.
So what I've done in the time between that last video segment and this video segment is taken a look in the subreddit polyamory at the text of a few handfuls of posts in which people mention sexual identity and gender. And for gender, at this point, I'm focusing on the binary of man and woman simply because those are the most commonly articulated. I want to recognize explicitly that there are non-binary gender identities and multiple ones of those. And actually, when working with larger amounts of data, hope to pull that out. So what you can see here is an Excel spreadsheet. And in this Excel spreadsheet, if I may make this a little bit larger, you'll see three columns. One of these is describing sexual identity, which is actually a combination of a sexual identity and a gender. So there's bisexual man, and then you can see down lower, bisexual woman. And then what I've done is gone through the text, and when someone is referred to as a bisexual man or a bisexual woman, I've looked for attributes, usually adjectives, that describe that person. And the attribute is in the second column. And then there's frequency for the circumstances in which we might have more than one occurrence. For instance, twice bisexual men are referred to as kind. Twice bisexual women are referred to as angry. The frequency 1 means that there was a reference one time to that. And if there's a 0, well, then I haven't put anything in at all, although it's important to recognize that. So, for instance, we do see that bisexual a woman is referred to as kind once, whereas a bisexual man is referred to as kind twice, whereas a bisexual man is referred to as beautiful twice, but there is no reference, if we continue to look down here, regarding a bisexual woman. Now, further below that, we'll be taking a look a bit later at the idea of what heterosexual men and heterosexual women as positions might have in their descriptions. But we could literally simply delete that for right now, and let's just focus on the positions of bisexual man and bisexual woman. These are cultural positions, you might say, statuses that have role expectations associated with them that are described in the text of these posts. So that's what makes these cultural positions. What are bisexual men and women described as being like? This creates a set of expectations. So this is the form of a list. And if we wanted to work with that list, we could head over to R, which is a program that can deal with that. And since we want to create a network, we can head to our script window in the upper left. And after having installed the package through Tools, Install Packages, and then selecting igraph, which I don't need to do since I've already done that, but you literally would just type in igraph here. We then want to activate it, and so that's our first command to activate library igraph. And then the second thing we'd like to do is to load that spreadsheet in. Now, in order to load a spreadsheet in, typically it's a best practice to save it in a universal format, and Excel files in spreadsheets are not universally readable. So I've gone ahead and saved that tab as a CSV file, comma delimited file, because a comma delimited file is universally readable through the command, and I'm going to read that into an object called list data. What is list data going to be? It's going to be read in through the command read.csv, which says to R, oh, go look on my computer for something. What? Well, in this case, for the option, and options in R are always included in parentheses, we're going to use the universal option file choose, which means, well, it's going to depend on the moment. And in this case, we're going to want to set the option header equals true, excuse me. Why is that? Let's just take a look back. Notice that there is a set of titles here in the first row, the position of sexuality, the attribute attributed to that, that's why it's called an attribute, and the frequency of that placement. So we need to note for R that the first row is a set of descriptors. It's not the same as the other rows, and that's what's called a header. Then it's going to get loaded in, but it's going to get loaded in as a general object. We want to do something to describe it particularly as a network, because if you think about it, each of these pairs of the position, say such as bisexual man, and the attribute kind is describing a relationship between the two of them. And in that sense, what we have here is a list of edges between nodes, or a list of ties between nodes, depending on which version of graph theory you use for vocabulary. The nodes are either position or attribute. In this case, notice that there are two different kinds of nodes, which is why they're called bimodal. And the relationship is between those two is described in a set of rows. That's one way to describe a network. So that's why I'm calling it a list network. But when we first read it in, R is just, all it knows is that it's some information. We want to turn it into a network. And we do that with the command graph.data.frame. And what is it that we're going to convert? Well, we're going to convert that object that we just created in line 3, which is called list data. And we're going to set a particular option that when we're setting the network, to let it know that just because one node exists before the other one in a list, one on the left, one on the right, there's no direction implied because it's just a general association between the two. So that means we're going to use the option directed equals false. And then we're going to want to convert that list into an adjacency network. And to do so, we're going to create an adjacency network, which is to get dot adjacency. And it converts a graph, general graph, to an adjacency matrix, right? And a matrix is where all the rows and all the columns can all correspond to one another. It's where the senders are in the rows and the receivers are in the column. So we're going to do that, and that's going to allow us then to work with it as an igraph object for a network. And what are we working with? We're working with the list network. And by the way, there's a special third category here, right? Or a third column. And that is, going back to the spreadsheet, frequency. This thing called frequency is an attribute of the relation, right? And so we're going to use, it's just a thing you have to know when you look at, you could look this up in igraph. The option ATTR, short for attribute, the attribute of the connection that we're going to be working with is called frequency. So it's going to look for that column that is labeled frequency, and it's going to say, oh, that's not like the name of a node, that's a description of the tie, okay? And then this is sparse equals false, just says, hey, you know, we want this to be a full matrix with zeros and ones in it. And then we could simply just plot the list network if we wanted to. And let's give that a shot. Let's see what happens when we do that. So when I do that, I'm going to want to run all the code, and I'm going to run that to run region, run all, to run all the lines. And then it's going to take me over here to this place where I've saved the file. And I would have to look it up, except I happen to know that it's cultural network, bisexuality. We're going to work with the list. And that's a CSV file. We want to make sure that we're not trying to open the Excel file as a CSV file because R would get confused. Oh, and then it's saying list.network is not found. Did I do something difficult? Yes, I made a mistake. Take a look at line 5. So I see down here in the console window, which is at the lower left, that that it goes well. It'll report all the lines that work, and then it'll stop at the line that doesn't and give me a red flashing, well, not flashing, but a red set of text that's identifying an error, and it's saying, what's this list.network? Oh, silly me. There was a dot that I put here in line 5, so I'll want to put an underscore. I make mistakes all the time, almost every time I type in a script, so, you know, it's not to be unexpected. But now I'm just going to try again. And by the way, to clear the console, I'm using Control-L just to clear it up, and so I don't have to worry about that. I'm going to clear out in the upper right. You notice there's some data here. I mean, I clear out all those objects, all the data objects, so it's nice and clear again. And I'm just going to run that code. Here we are. Now it's looking again for that CSV file, so I'm going to provide that. It's in the form of a list, a list of ties, right? And look what we've got here. Okay, so we have over in the lower right, we have a plot. Now we could, excuse me, we could zoom in by using the little zoom command here. And that gives us a much bigger picture, and it tells us a few things that are really interesting, right? Okay, so first of all, there are two connections here between bisexual woman and bisexual man. Bisexual woman as a node is connected to all these nodes over here, which are descriptions of bisexual woman. And then there's bisexual man over here. So while bisexual man is referred to as immature, good, frustrating, single, beautiful, wonderful, busy, intelligent, solo, poly, interesting, respectful, kind, and polyamorous. Whereas bisexual woman is referred to by a different set of items, such as pissed, non-monogamous, safe, devaluing, cool, level-headed, suicidal, hurt, guilty, secret, dishonest, bipolar, love bombing, uninterested, so on and so forth, and also kind and polyamorous. This is really a two-mode network created from the list, but it's one in which bisexual woman and bisexual man are treated as if they were just any other nodes. Fortunately, what igraph does is it tries to put nodes that are connected to one another close to one another, and that helps us to see the pattern. And we can see at the center of these sociometric stars, right? All these with the rays going out or in, they're all heading into bisexual woman and bisexual man. What this tells us is a picture. It gives us in a picture a description from just a few posts. So please don't take this as generalizable in any way. The cultural attributes that are distinct to bisexual women, distinct to bisexual man, as positions described in these posts, and then the two that are held in common. Not surprisingly, polyamorous as an adjective appears as a commonality, but also kind does, and that's something interesting to know. Now, we could do a little bit of work to clarify this. You may recall one of the things that happened was that we had some of these connections occurring in a way that had a higher frequency. And we should visualize that in some aspect. When they co-occur more often, how could we do that? Well, one way to do that is by modifying the plot command. So let's do that. We could plot that list network again. And then we could add an additional display option. Options are always in the parentheses. And in this case, let's make the more common, the more frequent ties, the ones that occur more often as associations in the text, let's make them have wider lines. And ties described in igraph as edges, they're just synonyms, can have width. And this is simply a command that you use to get it to work. What is the width going to equal? It's going to be equal to this thing called E, which is just referring to the aspects of the edges in the graph. Which graph? List network. But which attribute? The attribute frequency. And the attribute, the column is named with the prefix $. So list network $, frequency, okay, yeah, like so, separated within cascading parentheses, and one too many parentheses, it turns out, should give us a indication of width when we do that. So let's run this again. I'm going to run the whole thing all over again. And that's from our sample list, where we're looking at the conditions of bisexuality. And let's take a look at that plot now. By the way, we can always go back and forth through plots, previous plots, by using the arrows, right? And let's zoom in. Now you can see two areas where there are edges that are thicker. For polyamorous, which had a frequency of 5 with bisexual woman, there's a thickness of 5 for that weight. There were 2 instances of bisexual man and kind, so you can see heading toward the lower left of this picture, that bisexual man and kind are connected by a doubly thick line. And that's interesting because while these nodes, these attributes are placed equidistant between bisexual woman and bisexual man, they're actually, in terms of frequency, a little closer to one or the other. And that's what that edge width does. Now, you'll notice that we have a relatively small set of nodes, these attributes. That's because I've worked with, on purpose, a relatively small set of posts so that we could have something that's a little easier to look at. But what happens if you get more information? Well, one of the things you can do is you can change the size of the node, or you could change the size of the text that occurs to describe what each node is. So to do that, let's create a third plot, and that's again from the old list network. And we'll set that edge width just as before to be set to the frequency. Okay, but now let's set a third command, and we're going to separate each, option. We'll separate each option by a comma. Now let's make that vertex a little smaller so that orange isn't as distracting. And then let's make the label just a little bit smaller too, so that they don't overlap each other as much. And so these are the options, vertex.size, and you just play with these numbers until you get what you like. But one is vertex.size, the other is vertex.label.cex. CEX is just there because it is. And .cex is centered around 1, where 1 is the default. You can make it larger than 1. We'll want to make it smaller than 1 by just a bit. So let's set that to 0.8. And now, this time I'm going to, so we don't have to rerun all those options, I'm going to select one line, and I'm going to rerun the selected lines, which is under code, run selected lines. So just running that line, because the other lines have already run, we can see in the upper right that we've already created these objects in R. We don't have to repeat those. And, oh, look what we've got now. Let's zoom in. So on the negative side, we have smaller text. But on the positive side, it's nowhere near overlapping. And the size of the nodes is smaller. As a matter of fact, if we wanted to, we could make the vertex size equal to 0. If the color isn't important, if we recognize that the label is itself a node, we could set that vertex size equal to 0. Then I could highlight that line again, and I could just run that selected line again. And now notice, zooming in yet again, that we have the node shape is the text itself, and it clarifies things a little bit more, a little bit easier for us to read. These are just some handy options. Now, this is not the only way to treat the data. And Sarah Shugars and Sandra González-Bailón, who are writing Semantic and Cultural Networks, are thinking of them explicitly as dual networks, meaning that there are two different fundamentally kinds of objects here. Bisexual woman and bisexual man in this example are not just any node like anything else, like bipolar or guilty or uninterested or safe. They are something different. They're something to which those attributes belong. And for that structure, they point out, what we really want to work with is an affiliation matrix. And let's take a look at what that alternatively looks like over here, back in our spreadsheet, under the tab Affiliation. And I'll make this a little larger so you can see it more easily, excuse me. So here, what we have is not a list format in which there are connections between either bisexual man and bisexual woman and some attribute listed in just a list of rows, but we really have a matrix in which the rows are attributes and the columns are positions to which these attributes may be affiliated. And what's in each cell? Now there's numbers. A 0 meaning there is no occurrence. For instance, abused is not referred to for bisexual man, call cell B2. But over one cell over, C2, bisexual woman, and abused, there is one occurrence of abused being used to refer to a bisexual woman. Heading one row down, angry is a condition that is used to refer to a bisexual woman twice, whereas angry is never, value 0, cell B3, never used 0 times to refer to a bisexual man. If we head a bit further down, we can see kind. So here we see bisexual man has 2 characterizations as kind. Bisexual woman has 1 characterization as kind. Okay? So what we have here are affiliations and description of how much affiliation there is. The implicit zeros are now explicit in this affiliation matrix. It is not what's called a square matrix anymore. It's not an adjacency matrix in which the rows and the columns are the same and we're talking about one node heading to another. Instead, this is, by calling it an affiliation matrix, we acknowledge that it is a matrix describing some form of belonging, and that really matters. It's going to be treated differently through a different script. So let's head back over to R and let's open up a new script to describe this. Now this script is going to be a little bit longer because it's just going to use some different commands to load in that spreadsheet again, although we're going to load in a different CSV file, which is that tab saved as a .csv file under the Save As command in Excel. We're going to read it in, just as we did before, with the command library igraph, where igraph is the package that's being activated, although it's already been installed, remember, under Tools, Install. And then we're going to load in, first, an affiliation, a set of data, and we're going to use that old familiar command, read.csv, file.choose, and then empty parentheses because there's no options that we particularly care about, except now we want to make sure that there is a header. Why? Let's go back and take a look again at this matrix, this affiliation matrix. Bisexual man and bisexual woman are a set of headers. They're unlike the other rows. And header equals true tells R that the first row has a set of descriptors in it. And where are the row names? Row.names equals row 1. Okay, now we're going to ask next for the creation of an object called affiliation matrix. And that is going to take this general thing that R is just going to read it and say, okay, it's a table, I don't know what it is. And it's going to describe it as .matrix, that's a command. And what is it that we're going to work with? We're going to work with the previous object that was created in line 3, affiliation underscore data. So now, we're going to describe that not just as any old matrix, but a particular kind of matrix, a 2-mode network matrix, right? Okay, it's a 2-mode network. One in which there are 2 kinds of objects, right? The positions and then the descriptions of those positions, right? And that's called in the parlance graph incidence. It creates a bipartite igraph graph from an incidence matrix. Nice how they describe the commands as you go. Bipartite just means two different kinds of objects here in relationship to each other. So we want a graph incidence of the affiliation matrix, okay? And then we want to do something with that though, right? We'd like to create from that a set of two one-mode networks. Okay, this is where it gets interesting, because what we can do here, because we recognize first that there are two modes here, two different kinds of objects, that we can work with those. But second, and this is really important, the argument made by Shugars and Sandra González-Bailón in their piece Semantic and Cultural Networks, forthcoming from the second edition of the Sage Handbook of Social Network Analysis. As a chapter, they're saying what really is important is that having shared attributes brings positions in a cultural sense into closer proximity to each other. Two cultural positions, like bisexual man and bisexual woman, are closer to each other if they share more attributions, more similar expectations or descriptions of what such a person we culturally expect ought to be like. Second, if two cultural descriptors like cold or angry or kind have more positions associated with them, then those cultural forms are closer to each other, which is really cool. And that's what they mean by saying there are cultural networks of two kinds. Networks of positions and how similar they are to each other as defined through cultural attributes. And then networks of cultural attributes and how similar they are to one another based on how many positions are in common are associated with them. Whoa, okay. So to think about this really neat idea explicitly and no longer just saying, oh, these positions and their attributes they're all just nodes in one network like any other, we're going to sweep those plots away. I'm going to sweep the data away just to make things clear. And using Control L, I'm going to empty up the console. We want to then create a bipartite projection. That's a formal term, but what it means is that we're going to create two one-mode networks. This is through the multiplication of a matrix and its transpose. That's the math that's underlying it. You can look at Ron Breiger, The Duality of Persons and Groups, this 1970s Social Forces article for the mathematical description of that. But just you could take my word for it right now that doing so creates these two projections of this two-mode matrix, this affiliation matrix, and it creates two one-mode networks. One describing the overlap between positions and the other describing the overlap between cultural positions. We do that little motion with the handy igraph command. Actually, it might be a general R command. I'm a little unclear about that. I'd have to look it up. I think it's a general R command. Bipartite projection. Okay. Now this is going to create something interesting, okay? What it's going to do if we take the bipart projection of that two-mode network, the object that we described in line 6, it's going to create, if we describe it then in one-mode networks, and actually while we're at it, let's describe, we'll just take a look at that. And we'll stop there. It's going to create two different objects, and they're going to have different names. Okay, so let's take a look at those. Let's run all of this so far. And what I'm going to do here is we're going to take a look at the affiliation matrix, which I've saved as affiliation.csv for bisexuality. And that was fast, wasn't it? And now I'm going to open up the console, make it bigger. Okay. And we're going to see two objects described in text. The first is called proj1. Okay, you can see it went through all the commands without any errors. Boy, I was lucky this time, no typos. And the first projection, projection 1, is a connection of edges, right? And these edges are described as having connections between vertex names. What are they edges or ties of? They're ties of concepts that have, why are they tied? Why is abused and cool tied? Because they share a common position that is described as having both of those attributes. Similarly, angry and bipolar are tied because, by the way, it's bisexual. Women are described in the text that I've entered as both angry and bipolar, making those two cultural attributions, expectations for how we think someone should be, connected to each other. They're closer to each other because they're connected through this position of bisexual woman. Okay. Now, you notice in the graph description in the text, there's this handy line that says, oh, we've omitted several edges because it stops after a certain point and says, we don't want to blow up your screen. So if we want to see the whole thing, we're going to have to plot it. Okay. Now, there's a second projection. Okay, proj2. Okay, that's all part of this object that I asked to have described just by typing it in, one mode network, which is consisting of just one connection, the connection between bisexual man and bisexual woman. It's going to have a weight, okay, and I'm highlighting that for you. But note that those two are connected. Why are they connected? Why is there a tie? Because there are attributions like kind and polyamorous that are attributed to both positions. So, for that reason, there's a connection between positions. This is going to be fairly boring right now because we only have two positions. But in a moment, we're going to expand to 4 positions, and I'll show you how that can actually be interesting on its own. Now, I'm going to make that a little smaller, and we're going to want to plot these things, okay? But first, in order to plot them, we need to tell igraph to recognize these two projections, each as its own adjacency matrix. A matrix describing the relations between cultural objects and another matrix describing the relations between positions. So to do that, excuse me, I'm going to want to head back to the script. What I'm going to do is I'm going to create a name. I could name it Louise. I could name it anything I wanted to. But I'm going to call it projection 1 adjacency. And I'm going to then I'm going to put an arrow in. I'm going to say we're going to call the stuff on the other side of the arrow. We're going to give it the name projection 1 agency. And what is it going to be? It's going to be get adjacency, which is adjacency. Thank goodness, it's trying to correct my spelling. It's going to be turning a general graph object into an igraph object of an adjacency matrix, which then we can plot as a graph of a network. And what are we going to want to work with? We're going to want to work with one mode networks. And just one moment. Okay, so we're working with the idea of turning it into an adjacency from one mode networks. Which one are we going to want to have be called the projection 1 agency? Well, probably the sub object, again, which when we describe a sub object, whether it's a column in a data matrix or when there are two data matrices, we'll select one of the data matrices. It's a part. We do that with the $sign. It's not sparse, meaning it's not filled with empty information. We want it to be complete. And by the way, we're going to use that ATTR option again to say, hey, there is tie strength here. Sometimes things are more connected than others, and that here is going to be called weight. It just is what it is, and that's the value of the cell in an affiliation matrix. And then we can turn that adjacency matrix into a network object by saying, oh, it's not just an adjacency matrix, but we want to create a graph of it. A picture of a network is called a graph. And we can do that by calling it a graph from adjacency matrix, which is what it was. That's above. And then that's going to be proj1 adjacency is the thing that we're going to get it from, the thing in line 11. And then we are going to remind the computer of two things. First of all, that this is weighted. There are some connections that are stronger than others. And second, that here it's called mode. I know it's really annoying that these options are different for every command, but that's what you get when you get a set of packages written by different people. Here, this is called mode equals undirected. That's an option that says there's no direction to these ties, they're just associations. Now, we could take those two commands, and I'm going to select them and then copy them. And then I could head down and paste them below, and then just change the number 1 to 2 to say that, hey, we're going to be working with the second projection. So the first projection is between cultural elements. The second one is between the positions. Okay, and this is a general program to work with any such affiliation matrix that is affiliating cultural content to these positions that can have cultural ascriptions made to them. That's the power of, well, you just choose the file. It'll do the same thing for any such creation, any CSV file that is an affiliation matrix. That's really handy. And then we can simply plot proj1 network, and we could simply, the command is plot, and we could simply plot the proj2 network. Okay, and let's run that. And let's see what happens. Okay, so it got as far as reading this in. Now, I saved that second tab as its own CSV file, remember, which is the sample affiliation. So we're going to read that in. Oh, great. And then if we look over on the right, it went through all those commands very quickly, and it created two plots so we can use these arrows to cycle through them. The first plot, let's zoom in on, okay, is no longer containing a description of positions. There are no nodes that are positions anymore. These are relationships between attributes now. So we see three clusters. There's one cluster that are associated with similar positions in the upper left: bipolar, abused, guilty, love bombing, dishonest, secret, upset, uninterested, devaluing, non-monogamous, and so forth. There's one in the lower right that is associated with a second position, right? So the upper left, if you recall from the list, that's bisexual women, connects those all. So they all have a strength of 1. And then there's the ones in the lower right, which is bisexual man. And then there's polyamorous and kind, that are these bridges as concepts that connect the two sets of cultural concepts together. Neat. We then can move to what looks like a boring connection here between bisexual woman and bisexual man. Okay. We can do a little bit of further work to gussy these up a bit. For instance, we might want to put the weights in. So we could say that the, bit frozen here. we could take these plots and say, well, let's take the edge width equal to here the edge attribute of the projection 1 network by weight. Do the same down here, so that the edge width is again equal to the edge attribute of the projection 2 network of weight. And so we have all of those. We can do more things. We could make those the vertex size equals 0. We can make the text a little smaller, just as we did before. Vertex label.cex equals 0.8. You could make it 0.9. You could make it 0.7. You could choose any of these. We're going to take away the with vertex size equals 0. We don't need those orange circles to distract us. And now I'm just going to select these and run them again. I select those and I run code, run selected lines. Whoop. Okay, we have a little bit of a problem. Oh, what's the problem? A typo. This should be edge.attra should be edge underscore attra for attributes. I just typed that in incorrectly. That happens all the time. What you do is you look in the console window at the line that generates the red, and that's the first place you look. And you just fix it and move on. Oh, and now we have 2 new plots. Okay, and these plots, if we zoom in on this, we notice now are providing just a better visual emphasis of the words themselves. Also, the words are separated from one another because they're made smaller so they can fit. And that's lovely. We don't really have much tie strength to worry about because we really only have 2 attributes, right? That sharing could happen between. But what if we worked with a different source? Let's clear this console out. Let's clear the plots out here by the broom. Okay. And let's clear that out, the data by the broom. Just to start fresh. And what if we work from a new set of information? What I've done here in a second additional set of gathered data is I've gone again just to a handful. So please don't take this as generalizable. It's just showing the idea, not just looking at bisexual men and bisexual woman, which is great, but also descriptions of heterosexual man in the polyamory subreddit and heterosexual woman in the polyamory subreddit. And here are some attributes that were used to describe them. Some of them we've seen before, such as the attribute pissed. There's one that occurs again. Here's that list again. How often does it occur? And then we have an affiliation matrix now again. But in this case, it's visible, we now have 4 columns because we have 4 positions. And there are some new attributes that are in, like close and comfortable, that were not just used to describe bisexual men or bisexual women, but were used to describe once in what I've looked at, heterosexual man. Conflicted and controlling. Just beneath that, excuse me, are 2 descriptions that were used for heterosexual woman, but were not used for any, see those zeros, any of the other positions, right? And we can continue to go on and on, right? There are more descriptions because I've been looking at more text in order to do this. But we can use the same programs. I've saved for the list and affiliation tabs 2 separate CSV files, and I can use the same program to generate insights just like that for the new expanded description of text and the associations of now 4 positions with a number of different attributes. So let's start with the list again. This is the program, remember, that loads in a list. And I'm going to run it. And this time I'm just going to select a different source file. That's cultural network bisexuality and hetero list. And now you see over here we have both the original. Notice how that's a little bit, even when we zoom it, it's a little bit too much. That's why it sometimes becomes important to make your words smaller. So we're going to go to the second plot, the one that set the vertex size equal to 0 to take away the orange and made the labels smaller. That was the second command. And just like that, simply, once you have these tools programmed in, you can use it for cultural analysis after cultural analysis. Let's zoom in. And now we have a much more interesting network here. Again, remember that in this, working from the list format, the positions, heterosexual man here in the upper left, bisexual woman in the center, bisexual man on the right, and heterosexual woman on the left are treated just as any other node, which has its strengths and its weaknesses. And then there are these attributes, many of which are, especially because I've only looked at a small number of posts, are only associated with one kind of position. But now there are a number, safe, kind, pissed, guilty, that describe different pairs of positions. Heterosexual man and bisexual woman share safe. Bisexual woman and bisexual man share kind. Bisexual woman and heterosexual woman share pissed and guilty. Interesting cultural connections, right? But what happens then if we take out those positions and we allow for 2 network graphs? One that is describing the connections between positions, the second projection, and one which is describing connections between cultural objects, the first projection, projection 1. Well, I'm going to run this very same code. And you can see the code here again, right? But I'm going to select a different source file, one with 4 columns in it. And that's going to be called cultural network and hetero affiliation, because it's the affiliation matrix of the cultural objects with the positions. Oh wow! And here we are. Okay, let's highlight the plots, and let's go back using the red, blue arrow to the first plot and zoom in. Okay, now we're starting to see something much more interesting, which is the emergence of clusters of co-occurring adjectives. These are cultural beliefs about what different sets go together in texts. This is a visual representation of cultural clusters and some cultural bridges that connect the two, like kind, guilty, pissed, and safe, right? So this is a network purely of cultural elements, these adjectives, what adjectives belong together and kind of create these, what is an entity but a cluster with a boundary. I see 4 clusters here and 3 bridges. Then we can move to the second network, and let's zoom in on that. And again, I've gone through the options of taking away those pretty orange circles and instead just using the text itself as the label for the nodes. We have the strength of the connection according to the number of shared cultural items. So notice bisexual woman and heterosexual woman have 2 areas of cultural commonality, so they have doubly thick line. Bisexual woman and bisexual man are connected to one another. Bisexual woman and heterosexual man are connected to one another by one common term each in this example. Of course, if we wanted to get a fuller example, we could look at more entries than a few handfuls that I've looked at, so please don't take this as generalizable. But there's also some interesting structure here, which is that there are some missing connections. Heterosexual man and heterosexual woman have no tie connecting them, reflecting the fact that there are no adjectives that are used in the small set of posts I've looked at in this example that describe both heterosexual men and heterosexual women. Heterosexual man and bisexual man, also, there's no tie directly connecting the two. No overlapping cultural expectations as described in the text. And the third missing gap is between heterosexual woman and bisexual man. No commonalities. Where are all the commonalities? Through this literally intermediary cultural position called bisexual woman, which seems to have cultural connections to these other three positions. Now, imagine that we were able to work with this process and we were able to look through the text and we were able to look for, first of all, not just men and women, but non-binary positions. Second, to look for other sexualities, such as pansexual, omnisexual, asexual, right? Those would be really interesting to look at as well. And then what we would see is a much more complicated cultural network, not just describing the connections that one position has to a set of expectations for it, but the commonalities held between those different combinations of gender and sexuality as positions, and the clustering of expectations, so that then we can begin to say how many, despite the large number of now positions that we would measure, based on the expectations that are described, do any of them tend to cluster more closely together? For instance, are pansexual woman and bisexual woman described as cultural positions in very similar ways, so that, as some people say, oh, pansexuality and bisexuality are really equivalent? Or are they different? Are they the same or different for men? Are they the same and different for women? Are they the same and different for non-binary identities? Now, clearly, you'd need to take a look at more cultural entities, entries, descriptions, pieces of text in order to get that kind of resolution. This is a low resolution result. But any resolution is possible if you look closely enough and collect enough data. You can begin to create images that graph an actual landscape of culture containing two sorts of objects. The positions that people hold in terms of gender or sexuality in this case, but it could be anything else. It could be profession and level of education, for instance. And then the cultural expectations we hold for those positions. That's what a cultural network looks like. That's the work that Shugars and González-Bailón are showing the door to us for. And this is the means by which you can make it come about, through a pair of really simple scripts run in a free program called RStudio. The door's open to you now. What can you find in the culture that you study? Find out.